Hi, welcome. My name is Julia, and I am the curator and artist for the Art of Science program at the Institute for Genomic Biology at the University of Illinois. And our interdisciplinary institute not only supports an incredible array of genomic work, but we also work a lot to communicate our research to the public, and we do that in a variety of different ways. And here today, I have a special guest to ask some questions to and talk about as a participant of Art of Science. So will you introduce yourself and tell us a little bit about the kind of science that you do?
Well, so my name is Dr. Kadeem Richardson. I just got my PhD from the University of Illinois. Well, I can't say just, it's been like a year now. So I'm kind of old, I guess, but I have my PhD. I got it from the University of Illinois. Pretty much what I study is female reproductive health, and I also look at toxicology. So my main focus for my PhD while at the University of Illinois was looking at embryo development, well, pre-implantation embryo development, and how certain toxicants may interfere um, with their development, altering it or causing any form of mutations um, until it reaches the blastocyst stage. So that's mainly what I did for my dissertation project. So it was really fun, really fun.
Awesome. Thank you so much.
Mhm.
Um, so would you tell us a little bit about specifically what is featured in the original image? If you can remember, I can bring it up for you if you don't.
Yeah, so what we looked at in this particular image was we looked at embryos that were exposed to a phthalate mixture. And so what a phthalate mixture are, they're chemicals that are used in plastics. Unfortunately, these plastics, when they're in sun or they're just in heat in general, or microwave or whatever, they release these chemicals. And these chemicals, they actually can go into the body and they mimic hormones. So with
Mm.
these hormones, they actually have adverse effects on the body. They initially were only looking at male subjects, male studies like mice and all that. However, there's starting to be more interest in female reproduction, which it should have been there in the first place when we were looking at males, if you ask me. But so we're starting to look at that. So I had the ideas like, well, what does this do to embryos? Like we see that it may affect the uterus, but what about when um, women are pregnant or even animals are pregnant in general? Like, how does this affect them? So we took this mixture from various different chemicals that are used in these plasticizers, and we said, hey, like, what's going to happen? So what I looked at in this particular one was the 8 cell in the blastocyst stage. So we cultured these embryos from the zygote stage, which is from day 1 all the way to day 7. So 7 days that they're in this microenvironment with this particular chemical. And then we looked at E-cadherin. So E-cadherin is this molecule that allows the cells to stick to each other once they go through development. So we looked at 8 cell. You initially see it in the 8 cell stage. The stage consisted to the embryo implants into the uterus. So we dyed them with this with the bio antibody to see if there's any disruptions inside the of the E-cadherin due to it being exposed to this chemical. And what we did notice is that, yeah, it did actually have an effect far greater than what we thought in certain treatment groups compared to the control. And the control, which you're looking at now, is really pretty. Everything's highlighting together. But in the treatment groups, it was like really sporadic or the signal was extremely low. So it lets us know that the E-cadherin wasn't as strong as we thought it was. Some recovered, but a lot of them didn't. So this probably leads to implantation failure in women. So therefore reducing fertility rates of women. So it was pretty interesting, pretty upsetting to see that it actually can have this effect. This could, answer the question why someone may have fertility issues or implantation issues. So
Yeah, I was pregnant at the time we spoke, and
really,
it was one of the uh, control. They offered me to be one of the participants in the study for collecting all of the resources, and I knew a bunch of other women
oh
locally
really?
that have done it. Yeah, so science actually getting out to people close by to where the science
Yeah,
is
yeah.
going on.
Even though they did well, they got not the samples, but the whole, well, they got the urine from the women at Carl, the
Mm.
hospital. And they did analysis on urine to see like how much of this particular phthalate was in there. They figured out, okay, this percentages of this one's in there and that. So that's how we kind of came up with that formula. So we knew it was like real. It wasn't just something, hey, let's just mix some stuff together and let's see what happens. So it is based off like actual women,
Yeah.
what they were exposed to.
So in a more kind of general way, I was wondering if you could tell me about how science imagery influences your research.
Um, Actually, I love the fact that we have imagery in science the way we do now. I think it paints a better picture. I think something if I just were to tell me like, yo, I work with the embryos and this is what happens, they kind of listen. But I think when people see an actual image of immunofluorescence, it really captures their attention and they can see firsthand what's going on or what we're looking at or why the science we're conducting is actually important. I think when people hear, okay, well, we're looking at embryos or female reproductive biology, historically, I feel like women have never really been truly studied like certain effects that that can have on them in science. So I think now that we have these beautiful pictures that you can see firsthand, not only does it make people more aware, but it makes them more interested in it and take more heed into actually researching the effects that's going on with women as a whole. So especially with embryos, hey, if you want to have a kid, like you got to know what's going on with your baby and how to make it in the best possible environment for the woman to so the baby's healthy and her as well. So yeah, I really love it. And I love the fact that we have this in IGB, the core where I can do these beautiful images is like state of the art. And like even people ask me, like, well, where'd you go? I was like, well, I went to University of Illinois at their IGB center. So if you want to do like these pretty images, I would go there. I would definitely. So it makes it so much easier to analyze stuff and even get these three-dimensional images, what you all see now. Like it's not really possible to get this nice, beautiful round thing. Other labs, they have to use microscopic slides and they kind of mush them. So you don't really get to see the true essence of what it looks like, or it could be blurred. And with us having high resolution microscopes, being able to do 3D Z scans, like you see
Mhm.
everything, like what it will look like in the body. So it's great.
Awesome. Yeah, I really enjoyed working with your images and enjoyed hearing you talk about your work specifically because it really resonated with me, this idea that of looking at cells at these very early development stage and this sort of idea of how delicate they are. They're so small and there's only a couple of them, but then also how strong they are. Like it's insane that like life comes from these like just couple of cells coming together and duplicating.
It's like it's smaller than a poppy seed, and it's like we can see everything that's going on. And then just even, what I love about working with the pre-implantation embryos, I think it allows you to appreciate life even more because it's like this is so many steps it takes to make a human
Yeah.
or an organism in general. It's just like, and women have so many issues, nowadays. Well, always, but even more so now with chemical exposures. Like some women, they are infertile or they have miscarriages, and it's like, okay, this little cell is turning into all this. You have to appreciate life a lot more than what you do, especially when you see it firsthand. At least I do. Hopefully, other people will when they see the work and they can appreciate a little bit more of all the steps that it takes for a life to actually form. So,
Yeah. Thank you so much. I really appreciate it.
alrighty.
It was wonderful to work with your images and wonderful to hear about your work. Thank you.
Thank you.